Hello, everyone. Welcome. Welcome as you're just joining us today. Today is going to be another event part of our MEV Hackathon here, sponsored by Flashbots with Wintermute. Sponsored by Wintermute with Flashbots, excuse me, on that mix-up. Today is going to be a session on MEV, but if you aren't registered already for the hackathon, I will post a link here shortly to register. You can still register, as well as a recap from previous sessions from yesterday. You'll have all that info. But without further ado, we're going to introduce our speaker for today, Brock Smedley. He's part of the search engineering team at Flashbots, and he's going to have a great session today on MEV. Thanks so much for joining us, Brock. We'll pass it over to you.
Let's get started. So this talk is going to be a pretty basic introduction to searching on Ethereum. I'm just going to cover a broad range of topics and kind of introduce some common things, as well as some kind of deeper topics as you get more advanced. So without further ado, let's get into it. So this talk kind of assumes some experience developing on Ethereum. So if you have some knowledge about Ethers.js, that should be good enough. If not, it's fine. You'll still kind of get the gist. But yeah, I'm going to be sort of assuming that you're familiar with Ethereum. Okay, just a quick disclaimer. This talk is not free alpha, so I'm not going to tell you which tokens to trade or exactly how to implement a searching strategy. I'll give you the basics, and ideally with the information that I give you, you should be able to build whatever strategy you want. But yeah, certain strategies, I probably should not explain them too much. And also, obviously, not financial advice. So anything I say should not be taken to imply that I'm telling you should do something. It's all academic. Okay. So to understand searching on Ethereum and Flashbots in general, we kind of have to understand the architecture of Ethereum without Flashbots. So before Flashbots, there were basically two ways to send transactions to Ethereum. It was either through the mempool or direct to miner. So on the mempool, so the mempool is public, meaning that anything you send is visible to everybody who's running an Ethereum node. And that doesn't have to be miners. That can just be anybody who spins up a Geth node. So they can see those transactions coming in before they're mined. And that leaves you open to attacks based on whatever information is in your transaction. So for example, if you're making a large trade on Uniswap, for instance, somebody can see that trade and they can say, oh, that trade is going to make a large price impact. So I'm going to use that information to make my own trade. And so we'll talk about this more, but that can get pretty dicey. So if you want to keep your transactions private, another way to do it without Flashbots is to send it directly to a miner. And so this is obviously difficult if you're not a, oh, there's some mic here. If you're not, a security researcher or don't have really good connections, this is going to be really hard to do. This is something that people did before, like Sam Sun from Paradigm. I believe he's done this before for a white hat rescue mission. But yeah, generally it's kind of inaccessible to the public to send transactions this way. So Flashbots was introduced to solve this problem. So basically what Flashbots does is we provide a layer of privacy between users or searchers and Ethereum, basically the EVM. So how this works is, see this diagram on the right, we have the Flashbots relay, known in code as MEV relay. And this relay takes transactions or bundles of transactions, which are just an ordered list of transactions that are supposed to be executed atomically. And we send those to miners that are registered with the Flashbots relay. So these miners run MEV Geth, which is just a modified version of Geth. Well, I'll explain it in a second, but essentially, this is basically a private mempool. So miners connected to the Flashbots relay are sort of bound to this terms of service, and that's why you see the handshake emoji there. There's a trust assumption that exists here that miners aren't going to abuse the information that they're getting from the relay. Essentially, all these transactions that are coming through the relay, these are going to be generally MEV rich transactions. And if they were to go to the mempool, somebody could pick them up, take advantage of them. And technically miners have that same view on MEV Geth miners have that same view. But because of the terms of service, we're trusting them not to abuse that. And generally the idea is if they do abuse that, then they're kicked off the relay and they won't be able to earn profits from the MEV that they're just mining. So that's sort of the economic game that maintains the privacy that we have here. But okay, so that's sort of the architecture. Now let's look at how we actually send transactions to Flashbots as searchers. So on the right here, we have all these JSON RPC endpoints. So these are the endpoints that are exposed by the Flashbots relay. So just run through them real quick. Send bundle, that's pretty self-explanatory. You call this to send a bundle, which again is an ordered list of transactions. So this is specifically useful if you have a searching strategy that requires multiple transactions. Like you can do this in arbitrage. I'll talk about how that's a little bit inefficient later, but there's other reasons, like you might want to do a flash loan, or you might want to deploy a contract before calling a function on that contract. So there's plenty of reasons to want to send multiple transactions and have them executed in order. And, so that's how you do that. You call ETH send bundle. ETH call bundle is used for simulating bundles. So you would use this if you want to see what would happen if your transaction were mined, or if your bundle was mined. So you send your bundle to ETH call bundle with a target block, and it will just basically, it'll create a simulation that includes your bundle in that block, and it will tell you what happens, given the state of the block and what your bundle does to it. So you'll get information like how much gas it used, whether it will actually be included, or if it reverts, and some more general information about that. And then we've also got private transactions. So for instances where you only need to send one transaction, but you want it to be private, like a bundle would be, you can use these methods: send and cancel private transaction. And this is basically just like a shortcut way to send a single transaction to Flashbots miners. Then we have a couple Flashbots specific methods. So get user stats and get bundle stats. User stats is basically just to get information about your reputation with Flashbots. So I haven't introduced this yet, but Flashbots basically maintains reputations for individual addresses. So if everything you send to Flashbots is signed with your public key, and by signing those, that public key earns reputation. And the reputation is used to decide which priority queue that you go into. So there's two priority queues: high priority and a low priority. By default, everybody goes into the low priority queue, but as you continue interacting with Flashbots, eventually you get bumped into the high priority queue. And both queues work the same, but the idea is that the high priority queue generally just has less participants, and therefore you have a better chance of getting included in a block if you're in that queue. So that's how that works. And then bundle stats. This is essentially just a debugging method. So if you try to send a bundle to a specific block and it doesn't get mined, or even if it does get mined and you just want to know more information about it, you can call this method with your bundle hash, which is returned from prior calls, and a block number. And then that will tell you how much gas it used. It will tell you whether it was included or not, whether it was simulated, what times each of those things happened. And that's pretty useful for especially like time sensitive operations. You could see if you submitted too late, or you know, just general stuff like that. So these are the methods that Flashbots Relay offers. And then let's go to the left side and just talk a little bit more about some of the other tools that we offer around this. So for debugging, another thing we use is, or another API we expose is the Blocks API. So using this, you can get information about a block that was mined and all the bundles that were included in that block. So you can see, using this information, you can see if somebody else was competing for the same strategy, or if the block was full, or if it was mined by somebody who doesn't accept bundles from Flashbots, stuff like that. So that's a very useful tool as you're kind of getting into the weeds of it. And then we have a few official Flashbots clients that implement all of these methods in code in your language of choice. So we have one for Go, one for JavaScript, one for Python. I believe there's a Rust one too that we didn't write, but it exists. It's somewhere out there. But it's also important to know that you can just write your own. The library itself isn't very complicated. It's just it's basically an HTTP library that's calling these relay endpoints. So if you look at the source code for any of these, whichever one you're most comfortable with, and you want to write this in a different language, you're totally free to do that, and it's not too complicated. Okay, yeah, just good to keep in mind. Okay, so this is going to be the fun stuff. So real quick, I'll just introduce some common searching strategies and explain what they are for people who aren't familiar. And then I'll kind of talk about how to iterate on those strategies. So the very first, and I would say the most popular and the most common strategy is atomic arbitrage. So this is something that Flashbots enables with atomic bundles. Essentially, what you're doing is you're buying an asset on one exchange and selling it on a different exchange for a different price, with the goal of making a profit, obviously. I think that one's pretty basic, so I won't go too far. If you have questions, you can ask them afterwards. The second one is liquidations. So this is pretty common too, but it's a little more complex. So with a liquidation, you're essentially looking for somebody who's taken a collateralized loan, and you're waiting for it to be under collateralized. And essentially, when that loan is under collateralized, you can come in and liquidate that, and you recollateralize the loan and basically equalize the protocol and take what's left over. And it gets more complex because a lot of times the loan will be for a large amount, like say it's for $1 million. Most people don't have that kind of capital, so one thing you can do is to take a flash loan to do that liquidation. So that's where it gets more complex. That's where Flashbots really shines. But we'll talk about more about how that works in a couple minutes. The last most common strategy we see is front and back running. So front running is just putting a transaction in front of another transaction, and then back running is obviously putting a transaction behind another transaction. So a relatively well-known example of front and back running is a sandwich attack. So in this case, somebody sees a transaction in the mempool that causes a price impact on a certain exchange. And then what they'll do is they'll put a transaction in front of that transaction to increase the price impact, the net price impact. And then they'll put a transaction right afterwards to liquidate those assets and take a profit. And there's an asterisk here because front running, I would say, is unethical. When you front run somebody's transaction, you're actually causing a price impact yourself and giving them a worse price. So I would say be wary of front running. I don't advise it. I'm pretty sure it's illegal. So just keep that in mind. Okay, so those are some basic searching strategies. Obviously, it's not all of them, but I think those are the most common and important to know. So now let's talk about how to get the most bang for your buck on the strategies. So a really big component of searching is gas optimization, especially in a game like arbitrage, where you might be making less than $1 per arb. Gas optimization is going to be a really big deal, because if you're making less than $1 and you pay 50 cents or $1 for the transaction fees, then you're really not going to be making any profit. So the more or the less gas you can spend, the more you can optimize your code to make it more efficient, the more profit you're going to make. And if you're doing, if you're doing this 100 times a day or 1,000 times a day, that really adds up. Those little bits add up. So here's a few strategies for gas optimization. Again, I can't cover everything, but these are the most common and simple. So first, probably the most important, the most common too, is single transaction bundles. Essentially, what you're doing here is, instead of sending 2 transactions to do 2 actions on chain, for example, in the arbitrage example, one transaction would be to buy the assets on exchange X, and then the second transaction would be to sell the assets on exchange Y. So as it turns out, the actual action of sending a transaction incurs some overhead. So if you can encode those actions in a single smart contract call, that'll save you some gas. So instead of sending 2 transactions, you would send 1 transaction which calls some function on your smart contract, and then that smart contract goes and interacts with the exchanges and does the swap. Okay, next, efficient addresses. This one's kind of fun. I think it just looks cool. So on this contract on the lower right here, you see we have 12 zeros at the beginning of this contract address. So the reason people do this is because, well, in short, it's a little more technical than this, but in short, storing zeros on chain costs less than storing non-zeros on chain. So if your contract has a bunch of zeros in it, then you're going to technically be paying less to execute from that smart contract. So that's a pretty simple way to save gas. You might as well. There's plenty of tools online to generate addresses like this. So you just have to find something with a bunch of zeros, and it'll be a little bit more profitable. Okay, and then this one I'm really just gonna touch the surface, because it's its own rabbit hole. But Solidity, or really whatever, Viper, whatever programming language you're using on chain, it's really important to know the caveats of your language. Like, for example, in Solidity, there's 3 ways to send Ether. You can call the transfer function, you can call the send function, or you can call the call function. And each of these do the same thing, but in slightly different ways. So with the call function, you're getting some values back from the function itself, so that you can check in the code to see if the transfer succeeded. And that's really good for contract security. That's probably what you would want to do if you were writing a financial protocol where that's going to be a long-standing contract and people are interacting with it. But it turns out to not be a very good idea for doing searching strategies, because those safety checks end up costing gas. And in the pursuit of lowering your gas costs, you might consider using a less safe but more efficient method. And because Flashbots offers revert protection at the relay, then you don't actually have to worry about whether the transfer succeeded. You can just assert that the transaction does what you're expecting it to do, and if it doesn't, then you just don't send the bundle. So you can do this with simulations or reverts or whatever you want. Yeah, keep in mind, know the caveats of your language, and always optimize for gas. All right, next point is latency minimization. So this is getting a little more advanced, but I think it's relatively simple to understand. Essentially, in strategies where, well, for context, you only have about 6 to 8 seconds to send a transaction from the time at which a new block is preparing to be mined. So a new block, or a block is just mined, a new block is getting ready. Their miners are building blocks with incoming transactions. You have about 6 to 8 seconds to calculate your strategy, create the transactions, and send them off to the miner. And if you're doing a very compute intensive strategy, something that takes a long time to calculate, you might only have a couple seconds. So latency minimization is really going to help make sure that you get your transactions sent out in time and make sure you get included. So here's a few tips for minimizing latency. First one's multi-call. So this is basically a smart contract. Uniswap implements one. But essentially what it allows you to do is it allows you to encode multiple call datas. So say you wanted to get the balance of a contract, and you wanted to get the balance of a pool, like the reserves of a token pool, and you wanted to get some Oracle update. So that would be 3 calls. And if you send those calls one at a time, just with your Ethers library or whatever you're using, you're gonna have to wait for 3 trips back and forth from your node. And obviously this incurs a time cost. So if you can scale that down to 1 call to the network, then that's gonna provide you an advantage. So with multi-call, you can just encode all of these calls into 1 network call, and then get all that information back all at once. So that's a great tool to save some time. Another tool is local simulation. So like I mentioned earlier, the ETH call bundle endpoint on the Flashbots relay, it will simulate transactions, or it'll simulate a bundle for you, and it'll show you what happens because of that bundle. But yeah, like with anything else, you have to send this call over the network. So that's going to induce some latency. So one thing you can do to get around this is you can actually run MEV Geth locally, and you can just send the ETH call bundle directly to MEV Geth. So MEV Geth implements the same API as the relay. So you can actually just send this directly to your own MEV Geth node and do the simulation locally. And that'll save some time. The last one, getting a little bit more advanced, but worth noting, geographic advantage. So this is pretty common, but it's important to know that the closer you are to a server, the less time you're gonna spend waiting. So if you have searcher bots that are very latency sensitive, the best option, or you might have better luck spreading those servers out geographically. So being closer to different nodes, or being closer to wherever you're sending it, that'll give you a latency advantage. And that, you can go crazy with that if you want. I think there's probably a lot to talk about there, but I just thought I'd cover it, make you aware of it. Okay, so then last point is the state viewpoint, or mempool viewpoint. So to understand this, we kind of have to recap how the mempool works exactly. So when you have a node running locally and you're viewing the mempool, the mempool view that you get is only populated by the peers that you're connected with. And this happens through the gossip network. But if you're directly peered, well, the more nodes you're directly peered with, the more quickly you're going to be getting new transactions from different places. And so ideally, the more transactions you have in your mempool, the better opportunities you're going to have. So it's important to keep that in mind if you're using the mempool for your strategies. Okay, so advanced stuff. I think each of these are their own rabbit holes. So we can get into it in the questions, but I'll just introduce these and kind of give the brief overviews. So the first one, assembly code. This is a gas optimization technique. There are certain things that you just can't do in Solidity, specifically in terms of like reading, little bits of memory. Like for example, if you're dealing with a string in Solidity, when you read that string, it's going to read the entire string all the way through from beginning to end. But if you're in a scenario in which you only need 4 bytes from that string, then you can use assembly code to just read those 4 bytes and not unpack the rest of the string. That's just one example. This is a huge area, and it gets really complicated. So you have to do your own research there. But yeah, that's the overview. Next topic, reverse engineering. So this is just a way to sort of see what your competition is up to and how things work. So if you have a smart contract on chain, well, most searchers, if not all searchers, are not going to publish their byte or their source code, but you do always see the bytecode. So what you can do is you can take that bytecode and plug it into a decompiler, and then it will basically take that bytecode and generate new Solidity code that basically acts the same. And it's not perfect. It can't necessarily infer variable names, so you won't have like a really good idea right off the bat of what's going on. The names of the variables that it creates are like variable 1, variable 2, function 1, function 2. So you kind of have to like draw the map yourself and trace things out manually. But this can be a really good tool for understanding what a contract is doing and how it's doing it in a broad sense. And then on top of this, you can use stack tracing with something like Tenderly. So this will just let you step through the smart contract program, and it'll let you step through transactions, and you can just walk through the code and see what's happening, what it's interacting with, what kind of values it's generating and returning. And so if you pair that up with decompilation, you can learn a lot about a smart contract that way. I think it's a good way to just get exposure to new strategies, new ideas, new techniques. So good to keep in mind. Long tail opportunities. So basically a long tail opportunity is just a rare opportunity or an uncommon opportunity. So you're essentially looking for things that don't happen very often or things that nobody knows about. I don't have good examples of long tail opportunities because they're just so unique. But that's the meme right now is long tail opportunities, because there's no competition. That's something to look out for. So I guess keep your eyes open for those. Okay, symbolic execution. This is a pretty new idea. So for context, symbolic execution is a technique where you set the success parameter and then you give it some data to crunch on, like some inputs and some general definitions of what you're going to be doing. And then you give it a success definition, and the program just tries a bunch of inputs and works towards the solution that you specify. And so the idea here is, if you're using this for MEV, then you specify the winning condition as profitability. Like, more profitable is better. And then you give it, a basic definition of like the tokens that you're looking at, the basic definition of a trade. And then the solver just takes all that and tries to create the inputs for the transactions that you need. So this is a really new concept. I first heard this from Georgios from Paradigm, and I have yet to see or hear about people doing it in the wild. I may not be up to speed on it, But yeah, I haven't heard very much about it, but it is a very new topic. And if anybody out there is doing this, I'd love to hear from you. I haven't seen it yet, but it's pretty exciting, at least conceptually. Okay, and then the last one is kind of a joke, but kind of not. So psyops, psychological operations. So something you see a lot, especially on like crypto Twitter, is searchers who claim or act like they're leaking alpha, but are actually just trying to send you down the wrong path. So for instance, somebody might say that like this programming language is way more gas efficient and you should just start using it. So I heard this about Viper, but I actually went and checked out Viper, and a lot of the things that Viper does are actually more expensive than Solidity. I'm sure there's scenarios in which it could be cheaper, but I think the message here is always do the math yourself, because you never know if somebody's just making something up or is just completely wrong. So always do the math yourself. Always, check firsthand and see if something is actually worth doing. Yeah, that's the overview for advanced searching topics. I think that's about it. Here's a bunch of resources. I'll release the slides, or I believe, yeah, I'll send them to Steve, and they'll be on the website after the talk. But these are a bunch of tools that I use, and then these talks at the end. These are some talks from some pretty advanced searchers from MEV Day at the event in Amsterdam. So these, I learned a lot from these. I think you can too. I really enjoyed these talks. So check those out. Yeah, that's all I have for you. Thanks.
Will the Ethereum merge to proof of stake affect any part of the relay? Maybe they mean not
Yeah.
proof of stake, but yeah.
I got you. Yeah. Yeah. So, yeah, I have a paper coming out about this pretty soon. I believe next week, that will explain this a lot greater detail. But essentially, the searching experience won't change really noticeably in proof of stake. The endpoints that are offered in the relay will be the same. The architecture in the back looks a bit different. The term relay is a bit confusing because relay post-merge is actually referring to a relay between validators or proposers and block builders. And so the relay that we think of today, MEV relay, is, well, they're both called relays, so it's just confusing. So yeah, I think to answer your question succinctly, what we experience on the relay right now won't change. It's just the back end stuff that kind of changes. But as a searcher, you probably won't notice that.
Go ahead, Brock.
I just saw, what about OFAC? I don't have any information about OFAC. I've actually been on vacation this week, so I don't know if we've come to a consensus on this. So I can't really talk about that. But keep your eye out on Twitter. I think Hasu and Robert will be releasing information about that soon.
Muhammad, how do you know which miner has abused the privileged info?
Yeah. So this is kind of hard to identify, but essentially, we would just look for patterns. So if we see somebody doing a certain strategy and losing out to a competitor, and we notice that always happens when a certain miner is mining that block, then we can kind of infer that miner is front running that strategy. It's a little more complicated than that, but that's sort of the gist. Is we just kind of statistically analyze that, and then obviously, we have direct connections with the miners, so we would talk to them about it as well.
Great. Another question from Berwin. As more and more people start to use Flashbots, even for kind of regular transactions, won't MEV disappear as all transactions kind of become private?
No. So MEV, well, okay, so there's the idea of like harmful MEV. So like a sandwich attack, for instance, uses transactions from the mempool from people who aren't using Flashbots, and it takes advantage of those. So yeah, like sandwiching will go away as all transactions become private. But other forms of MEV, like arbitrage, they don't originate from the mempool. They originate from inefficiencies in the market making algorithms. So those will remain as long as the market making algorithms stay the same.
Amazing. Let's see. Are there any methods for seeing the internal function calls of a transaction in the mempool specifically?
Seeing the internal function calls of a transaction in the mempool.
Yeah.
Yeah, so basically what you would do in that scenario is you would just take the transaction and decode it locally. So if it's a smart contract transaction and you don't have the ABI, then yeah, it's going to look kind of garbled. But that's what things like Tenderly are for. So you can plug in a transaction there and step through it and get a better idea of what it's doing. But yeah, decoding a transaction from the mempool, it's like, it very much depends on where the transaction came from, whether it's on a smart contract, whether that smart contract is published as source code. There's a lot of considerations there to take into account.
Great. Another question from Henry. Since more than 80% of miners are running MEV GETH, in terms of client diversity, is this a threat? Is there any issues or bugs with this?
Yeah, that's a tough question. I don't, are there issues or bugs? I don't know that there's any bugs. But yeah, I mean, I agree that client diversity is important. And so actually in proof of stake, we're going to see a lot more client diversity. Yeah, I agree. It is non-diversified with MEV Geth. But post-merge, the way it works is, well, one, we're open sourcing our relay. I believe we just did. So you can use that relay implementation. You can create your own relay implementation. And then on top of that, there's a slew of consensus and beacon clients out there that are going to be running with MEV Boost. So that will be really good for client diversity. Yeah.
Great. Quick question from Prudiv. What is the economic incentive to maintain a Flashbot relay?
Are you talking about post-merge?
They did not specify, but I say let's talk about post-merge. Yes.
Yeah, the economic incentive to maintain a relay. Well, I don't know that there's an economic incentive as much as it's like an incentive for the health of the network. I think the economic incentive is actually more related to block building and block validation. So being a validator or being a block builder is going to be profitable. Operating a relay is more of like well, first of all, the relays are going to be sort of a short-term intermediary requirement to enable PBS. And well, I don't want to get into PBS right now just because that's such a rabbit hole on its own. I'm not sure it's going to be too relevant for this talk. But I do explain this in a lot of detail in the document that I'm releasing next week. So I'll post it on Twitter when it comes out, and you can learn a lot more from there.
Is there proof that this private mempool is like actually private? Deutsche Bank is also private, but they still front run big transactions, even though they're kind of an audited firm. So I guess that's kind of more talking about the private part of it.
Yeah. So I mean,
for a public company.
Yeah. It's private in the sense that only trusted actors have access to it. And that's why the terms of service exists, because yes, like miners can see the transactions before they're mined, and technically they have the power to front run or whatever. But the terms of service is kind of what binds them, and it's the economic game that they're playing. Like if they're caught front running with this information and they break the terms of service and they get kicked off the network, then they're losing out on tons of long-term profits, because just by being connected to Flashbots Relay, you're just earning passive income simply by including blocks with MEV-rich transactions. So that's sort of the economic game that they play. Is would they rather stay on for the long term, or do they want to risk it and potentially get kicked off the network?
Great. For any non-given Flashbot blocks, is there any easy way for us to tell our latency versus competitors so we know where we stand? For example, either scan doesn't give any information on when the transaction was received versus another inside a specific block.
Yeah, so this is actually something that we looked at pretty recently. I have an active PR actually right now on the relay that adds timestamps to the get conflicting bundles method in the Ethers library. So sorry, it's the MEV blocks API. So yeah, we don't have timestamps for competitors' blocks or bundles right now, but I am trying to add that in. I think we're going to do that. So stay tuned for that.
Amazing. Great question. One from Victor: how could we view min polls of alternative EVM chains, i.e. Avalanche, Arbitrum, Optimism, etc.? Also for kind of non-validators, how do they particularly win in this scenario?
Yeah, so the mempool is something that runs on the execution client. So like in proof of work, the execution client is also the validator. It's just like Geth or whatever client you use. Post merge, it works the same way. So you run an execution client alongside a beacon node, and if you're a validator, you also run your validator node. But ultimately, the mempool layer works the same regardless. You just have to run a node, an execution client on whatever network you want to see the mempool on. And that's it. Then you have access to it. You just peer with some nodes and you're good to go.
What do you think about the time it takes to start using Flashbots productively if you haven't used it yet and you're kind of a beginner? Kind of what is the learning curve to learn Flashbots?
Yeah, I would say it's not too steep. I think especially with the client libraries that we have, sending a bundle is relatively simple as long as you understand Ethereum development. So if you know how to sign a transaction, how to send a transaction to the network, how to listen for new blocks, I think that's going to be actually where the most learning is. That and getting comfortable with an EVM programming language like Solidity. But yeah, the learning curve for Flashbots specifically, I would say it's less about the Flashbots tools, and it's more about like understanding the strategy that you're chasing, understanding the competition, understanding gas costs, and how you're going to stack up against the competition. I think that's probably where the steepest learning curve is.
Great. Kind of switching gears here with kind of what's going on in the environment with sanctions and things like that. One question from Victor: can you explain how the Tornado Cash sanctions might affect kind of Flashbots, or will they? If not,
I actually can't explain that right now. We're thinking about it, but it's going to be up to the strategy team to answer that question. So yeah, I can't talk about that right now.
Great. Another person asked a question on OFAC blacklist. What about OFAC blacklist?
Yeah, that's going to fall under the same category. Can't comment on that right now.
Okay,
Great, great. Is there a trustless way to onboard miners via mechanism design instead of true TOS? Seems like an interesting problem.
Yeah, so I mean, this is something that we're working on in the proof of stake and PBS model. So yeah, with proof of stake and PBS, anybody can be a validator and plug into MEV Boost trustlessly and get access to all of the order flow from the Flashbots relay. And similarly, down the line, we want to allow anybody to be a block builder as well and have access to the validators that are connected to MEV Boost. So validators will be trustless off the bat in proof of stake, and then builders is sometime down the road.
Great, great.
And also more about that in the document next week.
Awesome. We'll be looking out for that. Make sure to, stay up to date with Brock once that drops. Can you go over the ETH parameters that we can tweak to increase the mempool size?
I don't remember them off the top of my head. Oh, you're talking about increasing mempool view. So basically the way this works is you have a list of boot nodes that you specify. So it's the boot nodes parameter, I believe is what it's called. I haven't looked at those in a minute, but yeah, if you just look through the, if you do geth -- help and look for boot nodes, you should see an option where you can specify which boot nodes you connect directly to. And so as far as like finding nodes to peer with, that's where you're gonna have to hustle and make personal connections and get to know node operators or find some public nodes where their enode address is published. Essentially, you just have to plug in those boot node addresses directly into your answer or into your geth parameters.
Great. Just a guest preference question here, JavaScript or Rust for kind of building a bot. Is there any drawbacks or benefits of each one?
Yeah, I love Rust. It's my favorite language for sure. But it is harder to learn. The syntax is more complicated if you're not familiar with it, and the tools are not as robust or well maintained as JavaScript. So I would say if you're just starting out, it would probably be easier to use JavaScript just to get familiar with the systems and sort of the way of thinking about things. But once you want to ramp up and make your systems really fast, then I would recommend Rust. It's much faster. Also, memory safety is a big deal. So yeah, I think that I would start with JS and graduate to Rust over time.
Great. Let me know if I missed any questions, everybody. I think I kind of have rounded it out here. Let me know if I missed anything, in anything you want to go for. I guess Rust versus Golang now. If you got a preference there.
I would say that's just personal preference. I think they're both really fast if you know how to use them correctly. So whichever one you're most comfortable with.
I think that's about the questions for today. Thanks everybody for joining. Thanks so much for our speaker Brock for joining us today and telling us a little bit more about MEV and going in depth into our questions. I know our community really enjoys and loves it. We will have our next event Monday, same time with Robert Miller. Let me post kind of a link to that. Another MEV session with him, going to be a great one. A reminder that all of these sessions will be recorded and posted online, as well as the slides from Brock. And we'll kind of post his Twitter as well for you to kind of follow him later. Thanks everyone for joining. Thanks again, Brock. We'll see you guys next week.
Thanks everyone. See ya.